And I'm live. That is pretty cool. Today is 18th of March 2026, Wednesday. And before beginning, a quote from Meditations by Marcus Aurelius. Let's see. Okay, this says, speak both in the Senate and to every man, whoever he may be, appropriately, not with any affect, affectation, use plain discourse. Okay, no matter what the educational level is or the man who you are talking to, you speak to them clearly, it seems. That is good enough. Mm, yep, cool. And we are going to give a virtual contest. That will be cool. Pop out chat, aerospace at work. Cool. The contest we are going to give is a educational, an educational contest. This one. It is 138. Let's start at 139. That would be cool. Okay, register for virtual contest as an individual participant. 42 seconds. That is good enough. Yep, there, new Vim, mini Vim. And yes, I would actually like to do a stream on my new Vim configuration, making it more clean and maybe adding a bit of documentation there also, so that if anyone wants to use it, somehow they would be able to use it. Okay, cool. And also Codium. Turn off to Codium. Cool. Okay, 7 seconds. Cool. I want to do at least 3 problems. Let's see how this goes. During a physical education class, n students are lined up numbered from 1 to n from left to right. For each student, it is known that if they receive the ball, they will pass it to either to neighbor on the left or on the right. On the right, this is specified by a string s of n characters. Each character of the string is either L or R. S I where okay, I the student, and for ball to the I minus 1 student and R I plus 1 student, the first student always pass the ball to the second and the last to the second last. In other words, that the string begins with the R and ends with the L. Consider the following process. First student receives the balls, then exactly n times the following occurs. The student who currently has the ball passes it to its neighbor. According to the rule, your task is to determine how many students will receive the ball at least once during this process. Okay, shit, that is okay. I think that is doable. How do we get the input? Taken as no vector and count size is n, everything is 0 initially equals 0 for int I equals 0, I smaller than n for int c in s, char in s. Yeah, for cr in n, if cr equals capital L, then c minus minus lc plus plus, and then cnt c equals 1, right? And then res equals count cnt dot begin and cnt dot end. Count the number of times we see our see out this. Shit, okay. How does this thing say 5? Okay, first put this thing there and then count. Yes. Okay, why? Then update. L, then go to left. R, go to right. And then end count. C begin to end the number of times we see 1. Uh, and cnt dot insert C. Shit, why does this thing say 7? At least once. Single line S. It asks us to determine how many students will receive the ball at least once during this process. All of these students are receiving the ball at least once. And this is a set. What is the problem for int x in cnt cout x some space 0 into 0 5 6 7 5 6? So what is the 3? How is the answer for this one? 3. In the second test case, in the first example, student 1 receives the ball and passes it to student 2, who returns it back to student 1, who passes it to student 2, and so on. Yes, so answer is 2 for this one. And for this one, we keep going, right? And this thing goes on for n times. N times. Should, of course, this is kind of messed up. Shit. Yes, shit, this is messed up. For int I equals 0, I smaller than n, I plus plus. Yep, to insert, and do not look for CR. The thing that we are looking at is the current thing. From there we move somewhere. So that was a bit stupid. Okay. Is this okay though? Let me increase the size. Looks okay. This should work. Problem number B. Running on test 1. Accepted. Cool. And this one, you are given an array A of n integers. While the array is not empty, an operation is performed consisting A of n integers. Array is not empty. An operation is performed of 2 steps. First, the maximum element in the array is chosen. If there are multiple maximum elements, the rightmost element is chosen. Then all the elements after the chosen element, including it, removed from the array. Thus, the task is to calculate the number of operations that will be performed before the array becomes empty. Before the array becomes empty, can we just brute force this thing? And this, I think we should be able to brute force this. We can have a set, right? Yes, yes, okay, cool. This we can brute force. Int n, take in n, and then is our array vector A size n integers for int reference x in a, c in x, and we will have a set of integers. I guess multi-set would be cool. Yes, we just want to sort this whole thing. Yeah, multi-set is cool. Multi-set ml, let's say a dot begin and a dot end. Cool. We have our multi-set for int I equals n minus 1, I greater than equal to 0, I minus minus, and c equals 0, or we could say res equals 0, and when we are here we are looking for the biggest element, right? And mx equals go to ml dot end minus minus. We don't even go to there, or do we have an iterator there? Now we will keep reducing I while I greater than equal to 0 and while I is within the range, and a I is not equal to, this has to be equal to the maximum number. We'll do I minus 1, and when we do find that maximum number, we erase everything, right? We erase everything, and also we must erase the number that we are skipping so that we do find the smallest number. Okay, for which we do ml dot erase ml dot find ai, right? Erase this number. Cool. And then res plus plus, right? And have we erased this number also? Yep. No, we'll have to erase this number, for which we just do ml dot erase mx, and we need to find mx again, for which I guess it would be cool to define mx here. I guess that is good enough. Hopefully, okay, shit, it is good enough. I'm thinking of maybe this might just mess up at some point. Let's see. Okay, we are taking in A. I do not want to submit this thing wrong. It just feels like everything is taken care of here. Everything seems okay. We are taking in X, everything. A, we are moving back from the right, and we are removing everything, and then we always have access. We always have access to the biggest number. Cool, cool. Submit. Shit. I don't want to get this wrong. That would be very sad. Accepted. Cool. Shit. My submissions. Cool. Accepted. Okay, and how was it? 12 minutes. Okay. Alice, Bob, Carol, and Carol visited a spring to collect water. Alice wants every A days on, okay, these Bob visits on every B days, and Carol visits every, okay, the three people. When only one person visits, they collect 6 liters of water. If multiple people visit, the water is divided equally between two people. Two people take 3 each, and 3 people take 2 each. Our task is to calculate how much water Alice, Bob, and Carol collect over m days, starting from day 1 That is not very difficult to do. Starting from day one, there are M days, and we have A, B, C, and M. Shit. We just output how much water each person gets. A, B, C, and M. Why is this thing zero? Because this dude like never comes. And we know that the total amount of water is already fixed. A, B, C, and M. Right. And what are the limitations? The numbers can be quite big, so it would be just to be careful. Long is cool. Right. And okay, long we have total. And so for each person there is a base. For Alice, then Alice has to share with Bob, and Alice has to share with Charlie, or like C person, and then Alice also has to share with them both at some times, which we have to reduce. Shit. Okay. A base would be M divided by A into 6. That looks good enough. Right. A base and A base minus equal. How many times Alice has to share with Bob would be M divided by GCD. No, not GCD, HCF. How do we calculate HCF? In LCM, there is a direct function with A comma B, right? Multiply. Okay, this is one number plus M divided by LCM of A and C. Multiply this whole thing by, this is for 2, so 2, no, 3. Half of the water will go away. Half of the water will go away. Right. And A base minus equal, where all three of them are there. M divided by LCM of A comma B comma C. Can we give three numbers? We cannot give three numbers. Calculate LCM of three numbers. We do LCM again. A B C comma LCM. Right. Multiply this by 4 long, or I guess this number is a subset of this number. Clearly. So how much do we add there? We reduced 3. We have to reduce 1. I think this is cool. Let's put this number somewhere. LCM all would be LCM A comma B with LCM C comma here. LCM all. this also has to be minus, because instead of 3 we are only getting 2 liters of water on those specific days, which are a subset of these days. I guess we can just copy paste the same. Yeah. uh, Substitute a base with b base. Yep. M by b, ab. Yep. And bc. Yep. And divided by LCM all. Substitute b base with c base, and here make this c, make this a, cb, and ca, LCM all, c out, a base space b base space c base. Shit. Okay, at least we got right for this one. Mm, LCM all is LCM all is cool. LCM all is cool. Minus minus. Is our answer higher or lower than the actual answer? Our answer is always lower. Here 3 lower, 3 lower, 3, exactly 3 lower. And here also, yep, answer is always lower than the actual answer, which means we are subtracting more stuff than we should. LCM AB, LCM. I think this is one of the basic things uh, in probability, stuff like that. A base, A base. This is cool. I think, yep, this is cool, but these two things are uncool. Make so much sense. Makes so much sense. This has to be plus. Let's see now. Shit. Almost there. One lower than the actual answer. Here, shit. And the answer is still lower than the correct answer. No, shit. Yes, we have to multiply this thing. Okay, let me create a Venn diagram in my head. Into 2. Yes, into 2. That is what we must do. Multiply by 2. Okay, cool. Shit. Just we have to take care of long now. Cool. A base, B base, and C base. LCM of all the numbers, and LCM. This LCM function is like takes big long numbers. Yes, this does take big long numbers, and M everything is long, so we will not go out. Cool. Okay. Submit. Problem number 3. Cool. Hopefully this should be right. Hopefully, I don't think this will mess up. Test number 4. Okay, cool. Accepted. Cool. That is pretty cool. Accepted. That took like 12 minutes to solve, but okay. Now, yeah, 2000 people have solved it. D, alternate path. This one is a bit difficult. Not a lot of people have solved this one. Cool. Let's also see our standing. How is the standing? Standing is friend standing. Shit, Umnik is at the top. Okay, yes, Kakashi, I am ahead of you. You have to catch up. Shit, you solved this one faster. And also this one faster. Shit, I messed up. I am stupid. You're given an undirected graph with n vertices and m edges. Undirected graph with n vertices and m edges. The vertices are numbered from 1 to n. The graph contains no self loops or multiple edges. No self loop or multiple edges. Your task is to make a graph directed by choosing. Your task is to make a graph directed by choosing a direction for each edge. After directing the edges, call a sequence of vertices. This where k can be arbitrarily large and any vertex can be repeated any number of times and alternate path if the edge this directly connected from this to this v2 v3, okay, and so on. Call a vertex v beautiful if all paths not necessarily simple in the original graph is that start at vertex v are alternating in the resulting. Okay, what is the maximum number of vertices that can be called beautiful after directing the edges? Okay, so at the base we have a graph which is not directed with n vertices and m edges. The vertices are numbered from 1 to n. The graph contains no self loop and no multiple edges. Okay, your task is to make the graph directed by choosing a direction for each edge. After directing the graph, call a sequence of vertices this where k can be arbitrarily large and any vertex can be repeated any number of times. An alternating path if an alternating path. What do they mean by an alternating path? Call a vertex v beautiful if all paths not necessarily simple is in the original graph that start at vertex v are alternating in the resulting directed graph. Are alternating to okay, shade 1 2 is directed from okay, shade 1 2 is directed from 1 to 2, and v2 v3 edge is directed from 3 to 2, then 3 to 4, then 5 to 4, and then 4. Okay, here this is the starting, this is the ending, then this is the starting, then this is, and this is the ending, then this is the starting and this is the ending, then this is the starting and this is the ending. Okay, shit, this seems like only even number. even number edges are the ending edges, and all the odd number edges are the starting edges, vertices. What is the maximum number of vertices that can be called beautiful after this thing? Okay, in the test case we have two numbers, n and m. Okay, this is going to be a tough one. Each of the following m lines contains two integers, uv and uv. We can make this an adjacency matrix. The description of edges of the graph. Additional constraints on the input. The given graph has no self loops, no multiple edges. Cool. Okay, and there is no information other than this. Okay, let's first of all take in the input. Nm adjacency matrix, vector of adjacency matrix, and size this, and vector int size m. Everything initially is, wait, size is 0 0 for int I equals 0, I smaller than m, I plus plus, right, L and R, C L taken R and ADJ, right, the size should be n plus 1 ADJ L dot pushback R is connected to L, and L is connected to R. Okay, and now we have to think. And I don't know. Maybe something is wrong. No one is actually like coming to this stream today. Usually a lot of people come in competitive programming stuff. Okay, we have, let's look at a simpler one. This one. There, wait, what? We do not have any edges. It seems we just have vertices. The first number is the number of vertices, and m is the number of edges. And in, okay, shit, this is the one. Here we have 6 vertices and m edges, and they are saying only 2 of them can be called beautiful. Excalia raw. There is one between 1 and 5, and between 2 and 3. Okay, 1 and 5, and between 2 and 3. We have to make this thing directed. We have left out 4 and 6. We have to make this directed. First of all, the problem is not very clear, like specifically what do we have to do. What if there is no edge between two things? 4, they are saying all 4 of them can be called beautiful. This and this. After directing the graph, call a sequence of vertices, this, where k can be arbitrarily large. Not necessarily the simplest. In the original graph that is started at vertex, we are alternating. This is like not very clear, and there is no explanation here at the later end. And was there something here? D, alternating path. In English version of the problem, D, the word any was used in the context from which it could mean both some and every. This has been fixed soon. Any path in the definition of a beautiful vertex means every path alternate. There was a mistake in the statement. The graph can contain loops but cannot contain self loops. Okay, Problem B is not here. Cool. Problem B is done. We are at C. Shit. Standing shit. Shit, 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 shit. Kakashi, you will take over. Shit. You will actually take over. There are four alternating vertices. Probably these four. Probably these four. And when the number of this is 0, then also this is alternating, I guess, because there is no edge, so k can be a non-zero value, so we can keep k equal to just 1 and keep that vertex, just only that vertex there, in which case answer should just be equal to n, but it is not equal to n. Here it is equal to n, but here it is not equal to n. Warum? Let's say we make the direction of this thing this 1 to 5, then we can say 1 5 1 5, because there is a edge between the odd numbered one, number 2, number 3, number 4, or we just care about the parity, we can just keep repeating 1 2 1 2 1 2. So all the one things are at odd places, so one should always be the beginner, which it is. So 1 is cool. 1 can be said to be cool. 1 can be said, yeah, to be beautiful. 1 5 1 5, if this is the direction that we give. And here also, in case of this pair 2 and 4, 2 and 3, we can say the same thing. And here also we can just say 4 and just be done with it, and 4 here also and be done with it. I guess that is why this thing says 4. Okay, cool. Let's look at a more complicated example. That would be cool. This one. We have 8 vertices. Okay. One connected to 3 and to 4. One connected to 3 and 4. Two connected to 3 and also 4. Right. And then 5 to 6. 5 is connected to 6. 6 connected to 7. 7 is connected to 8. 8 is connected to 5. 8 is connected to 5. 6 is connected to 8. Like this. We have to give direction. I think we can just choose something arbitrarily and do a BFS there. Do a BFS. Like here, this is level number 1. Or like this is our root node. If 1 is our root node, then 3 4 and 3 is at a depth of 1. In this case, all the edges will go away from the root, and then when we go to the next level, which would be 2, all the edges that we took to get there, their direction would be towards the root, something like this. So in the final analysis, we will have 1 3 2 4 1 3 2 4. Yep, because there is a node which goes from 1 to 3. Then we have to flip the direction like this. This, 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 which is true. Shit, which is true. So we can say this thing about 1. 1 is beautiful here. Like cool, pretty cool. And all the things which, all the nodes which have two edges pointing outwards are beautiful. 1 is beautiful. 2 is also beautiful. My bad. Okay, 1 is beautiful, 2 is beautiful. If this is, and I think, yeah, 1 and 2 are beautiful in this case. What about here? What about this? This is more complicated than that. Let's say we begin from 5. If we began from 5, first level would be 6 and 8. And what do we do with this one? Like self pointing, from 8 we can go to 6, from 6 we can go back to 8. And the answer of this thing is 2. I guess that just means there is nothing we can do about this. There is something we can do about this, but nothing to do about this, because here the size of the loop is, the size of the smallest loop here is odd. 3 nodes here and 3 nodes here. And when we have odd stuff, here we have even size 1, 2, 3, 4. Here we have the size of the loop is odd, 3 nodes in this loop and 3 nodes in this loop. So in odd we don't work, nothing works out, but when the size is even, then things do work out. Yep, and since we are using DFS, we would be cool. And since we are using DFS, if we reach, we can, yep, every node in a loop will have a boolean value, not a boolean, enum, nope, will have a integer value along with visited. Okay, shit, in the visited array, each node will have a value. It will either be 0, which means not visited, 1, which means going out from this, and 2 means would mean nodes or edges are coming into this thing. And that is the only thing we can do. That seems to be the only thing we can do. Okay. Visited, a vector of integers visited, right, visited, cool. And we can even make this ADJ vector global ADJ, and here ADJ dot assign v and vector base reference function perhaps. Do this and make this n+1, and here visited will have a size of n+1 also, where initially everything is 0. Cool. And then we fill up our adjacency matrix. Cool. And now we can call BFS. Shit, we don't even need these two outside, because for BFS we do not call an external function. Okay, that was stupid. ADJ size would be n+1 and vector integer reference. No, shit. vector visited size n plus 1. Initially everything is 0. Cool. And then we will make a queue of integers, give it a vector of integers to work with, and yeah, we'll just call it q dot insert 1. I guess it is not insert, but push it is. And response is 0, and we will update our final answer when we have gone through the whole loop. All right, okay, and let's say end out is 2 and in is 1. I guess we cannot have in, we can have in. That is cool. While q dot, while not q dot m, while q is not empty, get the first thing. Current is q dot front and dot q dot pop, get it out. Now we will go to all of its neighbors for x in adj of or we could also use I, which seems more appropriate. Okay, yep, and we also have the state, which is in. Yep, and I think switching the direction should not mess up anything. Switching the direction should not mess up anything. Cool. Okay, cool. And after this, when we are done with this, while q dot not empty, before this I guess for int I equals 1 I smaller than equal to n I plus plus, if visited I equals 0, then start a DFS from this location. Right, and res, we do not do res like this. What we do for res would be, we can actually use ranges, I think. And res would be rn count. Yes, let's go. Count visited, count out. Cool. Okay, count out. And the problem that we are doing here is this one. Out. So we, this x is something that we are reaching, so if x visited x equals in, that is fine, and or it is equal to 0, that is also fine, which 0 means unvisited, but out is not actually fine. If visited equals out, then this is actually messed up. Then it means in this loop, turn everything into false, for which we should also have into account. Okay, cool equals true. Here we will say cool equals false. Not specifically out, but if this equals 3 minus 3 minus the current state equals in. If C is 1, then visited cannot be 2, and if C is 2, visited cannot be 1. Then we say cool is false. Right, then we say cool is false. And even before this, we say if we will go through this whole thing. If not cool, if not cool, we will just say visited x equals 4. How about 4? 4 is very cool. 4 is very cool. 4 like is so much cool it does not even make sense. Else you do this. If not visited. If visited, q and also push x with cool being false. And when we get out of this thing, we say cool equals true. That is cool. Else, if uncool, then what do we do? Wait, if the thing is cool in the right position, then we do q dot push back x. We don't even need C. We don't even need C. When we start here, we say, like legit, we say when we, shit, what is up with indentation? Q visited I. Q dot pushback is not equal to anything. When we start, we say visited not 1 but I. Visited I equals in. In, and here we do not check with C but we check with visited I, which is C, and do this, push this thing back, and visited x equals 3 minus visited I. Is that cool? That is very, very cool. Yep, and if not cool, then and in this case also q dot push x, which means we are doing q dot push back in every case, which means we should not do it here. We should instead do it here. Okay, everything that is connected to I being the current thing, the current node that we are at, we go through all the nodes which are connected to I, right? And we check the coolness of this node of our state. If not cool, then visited equals 4, which makes sense. And also in this case also we should do some visited x equals 4 or something, and we are doing, yeah, we will start a new thing from this thing anyway. Yeah, visited 4 is only true if we are in a loop which is uncool, and also if we do go through a loop that is uncool, or if we go through a loop which initially seems to be cool. Hello, Rishi Gupta 5213, a very specific number. If you go through a loop which is initially uncool, but then which is initially cool but then becomes uncool, we need to keep track of the nodes which were cool before but then become uncool and make them uncool, which means we need some memory, which means we need to put stuff in some place, which means a set would be cool or a stack would be cool. Let's use a stack of integers which uses vector internally, and we call it st. Yep, and a single node will not go to this stack more than once. It will only go there once, if ever it goes there, right? And yep, we do this when we go here. st dot push I is current node if not cool, and then also if not cool, we need to change the visited value of all the things which are in the stack. While loop, while not st dot, while st is not empty, we get the top thing, top g, st dot front top, and then st dot pop, and visited I equals 4. Yeah, cool. And then make the coolness true. Okay, and at the end count the number of nodes which have out. That would be our answer, and hopefully nothing breaks. Shit. Q dot, while q is not empty, q dot front and q dot pop. What is wrong? In instance of void q pop, we are popping something that is empty, but we are checking if the thing is not empty, only then pop. I guess when we do front, it removes the queue, removes from the queue, but it does not remove from the queue. That is the thing. Q dot front C++ doesn't remove. It does not remove the element. For remove, we have to do pop. This is exactly what we are doing, but we are getting some problem with this. An instance of void q pop with this alternating path, name of the file, required from here, has no member pop front. We are not calling pop front. Q dot pop. The compiler is messing up, I guess. I guess it might actually just be, it is not just the compiler shit. compiler is using C++23, and the LS, I think LSP is also using C++23. So everything should be okay between the two. LSP settings are in library preferences, lang d, and I guess there is a file here, config.yaml. This is using C++23 for a C++ file, and also includes this thing which includes the bits and stuff. The name of problem was don't tell me undefined void has done the undefined void did do the problem in 18 minutes. Shit, I'm like shit at this. Alternating path, the alternating path. Compiler error is crazy, and it is not about this. C++ stack. '23. Is there something with stack? Stack is fine. Push range. C++ 23 q pop. It removes the elements from the front of the queue, which should be working. Why is this not working? Push some stuff onto the queue while not empty, get the front element, and then pop the front element. Why? Read the error, read the actual error. An instance of void like doesn't return anything, sequence pop integer. Shit, maybe because I have given here a vector. Okay, shit, that seems to be the problem, but we seem to be having a bigger problem now. While not empty, make visited I equals pop, and okay, we are doing pop here, and we are doing pop here also. Which is cool. It's cool. See out I. Which loops keeps shit something like just keeps running. This is bad, actually bad. Shit, this is taking quite a bit of space, and I'm not able to shit, how do we close new web? Age old problem. Shit, okay, this is not closing. This is okay, this is stopped. Okay, shit, this is actually not working. What is what? Shit, cool. Now it is working. Cool. The problem is some of this thing just keeps working. Visited equals 0. not visited. You dot push I visited I equals n. Yep, that should be the thing to do. Okay, shade makes sense. We are unconditionally doing this. Cool, cool, shade. Wait up. Cool. Okay. If not cool, then do. Q dot push makes sense, and if this, then also we must go Q dot push x, and here we will only go if not visited x, and I would like to turn off codium. Cool. Q dot push x. That was seemingly the problem. Shit. This thing has stopped working again. But I did save the file. I can just turn ghosty off, start it again. And what is this thing? 180, 450, 550, 630 probably. Yeah, cool. Competitive programming NT alternating path. Shit, there is some problem with assistant neovim plugin, which I'm using for getting the current problem and using that current problem. That is why this seems to be lagging. Shit, I'm like way behind. I'm actually way behind. Okay, shit, this thing just stopped, and I hope the streaming is not buffering. Let me check. Nope, stream is going flawlessly. That is cool. Close ghosty. Shit, I messed up this one. Okay. Competitive programming ND alternating path, and compile this. Okay, and run this with the input being this. Enter. Shit. My bad. New 15 standard should be 23, and compile the alternating path to dot slash out. Shit, did you mean standard C23? Shit, yes, that is what I meant. Ranges is not a name. Ranges is a name place in standard 23. Not for C++. Wait, command and option standard. Okay, shit, I meant in that case standard is C++ 23. Now it is our name, please. Okay. The input is this. Paste. No problem. And what do we see? We don't see shit. Alternating path. Okay, something just keeps on going on. Keeps on going. There are two while loops which might be messing up. This one and this one, but I guess both of them are cool. There actually is no problem with any of them. And we don't even have to do this if check. We can just do this while directly. Visited I equals nq dot push I. If not visited I, that is a different problem. See out I and slash for this paste. Okay, we see one and then nothing happens after one, which means we are stuck inside something. See out I. Compile, run. That took 1 second to compile. Okay, we keep switching between different things. 1 2 1 2 1 2 1 2 1 2. Okay, we keep switching between 1 2 1 and 2 1 and 2 1 and 2 1 and 2. If not cool, then this. If cool, if not cool, yep. Else if x. If not visited, then pushback. If the thing that we are at right now, if the thing that we are at right now is 3 minus visited I. Visited I initially is n, which is 1. So visited x if that thing equals 2 1 2, and this is happening for the first test case. Let's do this intentionally for this test case. For this one 6 2 1 5 and 2 3. 6 2 1 5 2 3 1 5 1 5 1 5 1 5. We keep switching between 1 5, and because of which see out 1 and 9, right, and 2 1 test case 6 2 1 5 and 2 and 3. I guess instead of 1 we should make this 3 and we should make this one 4. Compile, run. 1 test case 6 2 1 5 2 3 and cool. We just keep switching between 1 5 and we never get to this. I guess it is because this thing at some point becomes uncool. Shit, if the thing becomes uncool and not visited and not visited x, and we have not visited x, only then. If we have visited X in any way, then do not go there ever again. Have this blanket term outside. We change visited to this and go. Else we do know that else this is the case. So we can even put this q push outside. If visited X value is anything else other than this, shit, nope. If it is anything else, uncool, if we are uncool and the current thing that we are at is not visited, or if it is 4 means uncool, 4 means uncool. File one test case 62153. Cool, and answer turns out to be 2, which is completely fine, and the final answer is count in this and r plus rn. Count in adj dot give a lambda function takes in auto x. Shit, we should not be using codium. Shit, my bad. Codium was on, I didn't notice. Can this thing take a function? Expected body of lambda expression, that is very, very cool. If this thing takes x and return x dot size, return x dot size, no matching function call makes sense. So we have to manually do this second one. So do not output. I still feel like there is some mistake. Shit. Assistant neovim is totally messed up. Shit, I'm like way behind the curve with this one. Yep, actually, way behind. Shit, my speed was like maybe kind of comparable to Omnic, but probably he was doing his own stream. Yep, probably. What is 24 into this 150, 300, 300 plus 1500, 1800? Probably full. And ND alternate paths. Compile, run, where input is this, and shit, I didn't even see what it said. This said 2020, which is pretty cool. We just have to do for auto x in adj res if x dot size, if not x dot size, let's put this. If the thing is 0, then shit, I messed up again. CPP assistant is not working. Force assistant, nvim dot assistant is not working. So this would be 500, 2000, 2000. Okay, yes, 2000 plus 120, 2100, 2120, 2120 plus 53, 2100, 2120 plus 53, 73, maybe. Okay, how about now? That was not the right thing to do. Here, copy this. Cool, we are getting the wrong answer. Shit. 0, 3, 5, 5, 2, which is wrong. This should be 2. How can this be like this? Yes, because makes sense. Because here we have to start from the second one. For int I equals 1, I smaller than equal to n I plus plus. If not adj I dot size, then rest plus plus. Compile and run. Set 2 4 4 1, which actually is the correct answer. But the problem is this might just backfire. This might be like just working for this and not for anything else. And I'm also not very sure about all the things which are here. Int I equals 0, q dot front, q dot pop. Only if these things are not visited, then go inside. Okay, is this cool and not visited? Cool, that is cool. If not visited, but if visited, okay, if not visited x, if this thing has not been visited ever, then check for the coolness. If not cool visited, x equals 4, and q dot codium should not be working. Encode forces codium toggle q dot push x, and cool is already off. Else if we are cool and the current thing is also not visited, that means visited x equals 3 minus visited I, and q dot push. In both the cases we do q dot push, so it can be done commonly here, right? But if this thing is visited, wait, not just L, yeah, that is cool. If not visited, either cool or not cool. Else, if the thing is visited, then we don't care about the coolness. We care about if visited x equals the opposite of its parent, which it should be. Wait, shit, I messed up. I messed up. Uh, Visited I. In that case, cool equals false, right? Cool equals false, and visited x equals 4. Else, if that is not the case, then we don't check for anything else. Cool. One test case 6, 2, 1, 5, 2, 4. Does not matter. 4. Cool, we are still getting the correct answer at least for this. 3 is not what we should be getting for the first one. We should not be getting 3. Where are we getting 3 from? From the count. We are getting 3 from the count, which should not be true. If not visited x, and if not cool, then x equals this. And yep, at the end, do go through x pushback. That is only do pushback of this. Yep. If not visited, either we could be cool or we could not be cool, and if we are cool, then update. Otherwise, do not update. And yeah, wait. Only do this stack thing if not cool at the end. If it turns out at the end the thing is not cool. Now it says 0, which is crazier shit. Why is this thing not cool shit? If visited x equals visited I. In case of this one, visited I 1 would be equal to, let's say, 1. Visited 1 would be equal to 1, and for 2 it would be, for 3 it would be 2, and for 4 also it would be 2. And then when we get to 2, we will get to 2 twice, from 3 and also from 4. And when we get to 2 from 3, we will make this equal to 1, and from 4 we will make this equal to 1. And problem only arises when these two things are like equal to each other. This 2 equals this 1, which is not the case here. So we should be happy, but we are not. Compile. run for one test case where there are four things and four edges, four nodes, one connected to three, one connected to four, two connected to three, two connected to four, and the answer is two, which it should be equal to. But why did this thing say zero beforehand? Again, zero. Cool equals true initially. Copy y. But okay, this makes so much sense whenever we go out. Shit, okay. Not good. Else st dot remove everything from this thing, while not st dot empty st dot pop. Empty stack in C++. How do we empty the stack? Clear the stack. Compile for this test case, and I want this to work. 2 4 4 1. Okay, my bad. I want this to work. Let's see how this goes. D alternate path. Okay, this might fail. Wrong answer on test case 4. Wrong answer on test case 4. Shit. I messed up big time. Shit. Should be working, but this is not. Hello, Kakashi. Where are you? I don't get why this is wrong. Maybe, probably I'm doing here something that is more complicated than what is needed. Yep, probably. Probably. And shit, probably I am doing something more complicated than what is needed. Yep. Yep. Shit, yes. We don't need any of this. We do not need any of this. Yes, we do not. Shit, I guess this is also cool if I change this from in to out, from out to in, for when there is no loop. Okay, this is a gamble. Let's see if it pays off. Probably it won't, but let's see. Okay, 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 okay. Shit, okay, wrong answer on test case one. Yes, gamble paid off. 8. This is 8, which is actually messed up. This thing says 8. No matching function called print vector in C++ using print call. I think there is a way to directly print a vector like this. Println. For this one, copy. For first. The answer for second is 8. That is not even possible. It is possible though. It is actually possible. We remove this line. Compile to shit. Yes, this thing is possible, and 2441. Probably that was the mistake. 441. Copy now, submit, and this should work. This should work. This should work now. Hopefully. Okay. Wrong answer on test case 3. Wrong answer on test case 3. Okay, I guess there was a problem in the understanding. If there are no, there is no problem with the understanding, because yep, this should have been 2. Yep. From here we can go to here, from here we can go to here. Yep, we could have said 5 6 7, 8, 5, 6, 7, 8, and given these things direction like this. Out. If not visited, then out. In out does not matter. Arbitrary terms. Shit. This actually has taken me more than 1 hour and still there is nothing. 4,000 people have done this, okay. Combine. If not visited, size of visited is n plus 1, right? Yep, n plus 1. Adjacency matrix is also of size n plus 1. Initially every matrix here is cool. Then we have a q in out value push visited I equals in or out q dot push this onto the q, right? Push this and the stack. Yep, because we need everything that goes into the stack here. Yep, get I, push I onto the stack, and I x adj I. Go to every x that is connected to I. If it has not been visited, and look, if it is not cool, then make it 4. And if it is cool and we have not visited this, then make it 3 minus visited I. Yep, those two are the only conditions, only things that are possible if not visited. If not visited x, either cool or not cool. But if x is visited, then cool equals false. It is not cool anymore to do anything with x. But this does not work somehow. There's some problem. It is working here on the test case, but there's something wrong on test case 3. Shit, that took quite a lot of memory, I guess, because of the map, right? These like first 3 problems were very easy, but the D is messing up. And rank, what about the rank? Probably my rank is like in 4,000 or even worse. Yep, 4,000. 900. Shit. Kakashi bro actually did it. Pretty cool. V1, V2, V2, V3. Maybe there is just like a misunderstanding in my understanding of the problem. Let's look at the next one. Let's see sum of digits and again. Okay, what is this? For a positive strictly greater than 0 integer x and the string x, Sx is formed through the following process. Initially, the string is empty, then the decimal representation of the x without leading zeros is appended to it on the right. After that, if x is smaller than equal to 9, the process ends. Otherwise, x is replaced with the sum of the digits of x and the process returns to step 2. Okay, for 75 we put 75 and then sum of 7 and 5 is 13, 12, then we put 12 and sum of 1 and 2 is 3 and then we stop. Here it is 303. Cool. You are given a string s consisting of digits. Your task is to rearrange the characters in this string so that it forms the string sx for some number x. Removing characters and or adding new characters is not allowed. If the given string s is already for some number x, you may leave it as unchanged. Okay, this is very good. This is pretty cool. This is pretty cool. We have to rearrange this. So we do know that the last number is going to be 9 or smaller than 9. Yep, a single digit number, 9 or smaller than 9. Then for the number before it, so do we go through this thing and find, and we also know that 0 does not come at the start or at the end. 0 always comes in somewhere in the middle. For this one, they put 9 at the end, and okay, or we could put 2. Whatever the single digit numbers are in this thing, there are 9, 2. One of the single digit number will come at the end, and that number must be a sum of two different numbers, and the length can be very big, 10 power 5. Here we have 1, 2, 3, 5. Okay, 1 we cannot choose because 1 is not a sum of any two other numbers. 2 is not a sum. 7 is a sum of 2 and 5. Pretty cool. 7 can be a sum of 2 and 5. But then we need 25 to be a sum of something else. So not very cool. 3 is a sum of 12, 1, 2. There is a formula that we have to apply here. Shit. There is a formula. There must be a formula. 3 is a sum of 1, 2, which is a sum of 7, 5. Cool. And in this case, 7 is the sum of 6 and 1. 2 cannot be a sum. 4 cannot be a sum. 6 cannot be. Yep. 7 is the only choice. 7 is a sum of 6 and 1. Then something has to give a sum of 16 or 61. And I guess if this thing cannot be very big, this thing legit cannot be too big. initially x, it is possible to rearrange the digits in s to obtain this or some positive integer this, and the sum of length over x over all the test cases does not increases, and s can be very big. S can be very big. Okay, so it is always good to start at the end and then speculate what could be, what could have gotten us there. 16 is the sum of all this. 5 can be a sum of 2 and 3, but 23 is not reachable if we arrange 1 and 7 in any other way. So we go with 2, I guess brute force, because there does not seem to be anything else here, brute force. But how brute force? If there are multiple choices for getting a sum, which choice should we go with? Hello, Kakashi said, I was waiting for you. You did very, very good in this one. Shit, I messed up. I messed up quite a lot. Look at this. And still, I have been not able to do this. How did you do this? Problem number D. What I am doing is nodes. Yes. My way of approaching this is a bit more complicated. I should fix that later on. But essentially, it is this: start from a node, make this one, let's say 1, 2, and then 1 and 2. Keep doing this 1 and 2. And yeah, start a DFS from a random node which is not visited and run your DFS till the end. And it could happen whenever you reach a new node. If it is 0, it is not visited, then make its value equal to 3 minus the value of the parent. So if the parent was 1, then this would become 2, and if the parent was 2, this would become 1, whatever. And if this thing is already visited, either it is 1 or 2. In that case, if it is 1 or 2, this value should not match its parent's value, right? So yep, and yep, if the value does not match its parent's value, like 3, 4, let's say these are the nodes. D not solved. Yep, this is what me doing. Let's say in a certain loop or in a certain component, we are categorizing half of the nodes in one way and all the other half in another way. And yep, so let's say if we have to divide all the nodes in a certain component into two halves, and there is only one compatibility rule, that is the color of the parent cannot be equal to the color of the child. And if a certain component fixes that, that just means we can here make arrows like this. And this is cool because now we can write a sequence like 1 2 4 3 1 2 4 3, where 1 is beautiful and 4 is beautiful. And this works because categorizing everything in 2 works because in the original question problem, if you were to write this pattern, then all the odd number, all the nodes which are at a odd place have things going out of them, goes to, yep, goes to 2, 3 goes to 2, then 3 goes to 4, and all the even number of nodes have edges going into them. Bipartite problem. Yep. Yes, yes, it is a bipartite graph. That is what it means to divide the graph into two halves. Shit. Now this is not bipartite. Shit, that is what it means to divide a graph into things where shit. Bipartite graph, that is what you call a bipartite graph. That is like the legit definition of a bipartite graph. Shit, okay. That was just my stupidity. What do you think about problem number E? Problem E is pretty cool. Shit, bipartite graph. What do you think about E? E is actually crazy problem. E is actually crazy. We do know that the last number that we ended with is going to be some number at the end, and then before it is going to be sum of that number. Like verifying is pretty easy. Verifying is pretty easy. This number is the last number, and then keep going to the left, make the sum, find the sum. When your current, then keep going to the left while the sum of the numbers is not equal to your current number. Here current number is 9, whose sum we do reach when we cross these three problems, then these three numbers, and then the current sum becomes 252. Then we have to go left till we get to this sum 252. Okay, shit. First thing is one digit, then before it, what can be the smallest number possible? The smallest number that we can have at the first position is going to be 2. And then before that, the smallest number that can give us 2 is going to be 11. And to get to a sum of 11, we can again have the smallest number that can give us a sum of 11. The smallest number that can give us a sum of 11 can be 29 when we sum the digits. I think 29 is the smallest number. Yep, it seems so. 29. And to get to a sum of 29, the smallest number, shit. Even if we were to go all out with 9-digit number with this, we will not get to that sum. So we must use 4-digit numbers. Shit, we have to use a 4-digit number. Right, so we must use a 4-digit number here. And which case are you talking about? I saw your code. I think you are always thinking in case we need max or in or out. I just messed it up. I messed it up totally. E was tough. Yes, E is tough. E, I guess, is tough because we have like no idea what to do here because it is unfamiliar. But I guess once we do solve this after the contest in another stream, I would like to look at the solution of this one. This is cool. E. Wait, but did you do E? Hello. I am doing cool. How are you doing? Chilled Nick. Look at this. We solved some problems here. Like guess passing the ball. Wait, how is your new Vim journey and your code forces journey? This problem, I guess you will be able to solve. This is pretty cool. This one. And also F1 has started, which is cool. And I heard that the F1 which took place in China was a mess somehow. Like McLaren's car didn't even start. That was funny. And yeah. And we are right now theorizing about this problem. Problem number E. This one is E. Not for PS3 yet. I guess his car also messed up. They like, yeah, something also happened with his car. Shit. They are like falling down or something. Okay. What I'm trying to do here is in E, trying to find out how big can we expect to go, and maybe brute force is a viable option here. 29. What is the smallest number that can give us a sum of 29 when we sum up its digits? For shit, I think here we can start with 1. Yes, 1 can be the small. 1 is legit the smallest positive number, and the smallest number that can give us a sum of 1 is 10. Right, and the smallest number that can give us a sum of 10 is 19. 19, yes. And the smallest number that can give us a sum of 19 is going to be a 3-digit number, because if we were to max out our 2 digits, we would get 18 at best. So we must use a 3-digit number, where since we want to minimize the number, our highest order digit would be 1. Then we need a sum of 18, which is like what is left over. So 199 would be our next number. Then we need a sum of 199, which is big, which is actually big. How many nines can we use? 9 into 10 is not even enough. 9 into 20 would be 180. So if we were to like take 29s, shit, that is also not enough, because that would give us a sum of 180. We need 190 this, so 22 would give us 98. So yep, we need a 23-digit number. The jump is crazy. Initially we had a 1-digit number, then 2, then 2, then 3, and after 3 we need a 23-digit number. Shit. And this is when we started with the smallest number possible, which is 1. Yeah, not even single. Grand Prix start. Yeah, crazy. I am amazing. How are you? Shit. Yes, why? Even on first Grand Prix, his car hit even before starting the race while he was moving to the grid to start. Yep, he messed up. He messed up. No, no, they are messing up. And I think the problem is with the car's battery, which I don't know. I was watching a video and he said that battery problem stays throughout the whole season. It came to a halt. My journey in CF and NEOM key work and shit. At least you have a reason to be stressful. We here do not even have work and we are stressed out all the time. This reason is crazy. This season is crazy. They have a rocket ship. Shit. Shit. Some people call it a tractor. I guess cool. I think we can brute force this shit. can we brute force? But like figuring out a way to brute force is very brutal. 5,000 rank is crazy. Okay, after this we need a 23 digit number which starts with a 1 and has like 22 nines after it. This is a 23 digit number. And then should I think that then we are done. Then we should be done. Okay, share 23. We need nines, 9 pa 9 into some number x equals this behemoth 1 9 9 9 9 9 9 23 times 22 times 9. So we need x is like how many nines we need, or we can do -1 and we will get exact value of x. So let's do at one shit big number calculator, very big number. This is like actually very big. This cannot even be registered in a 23 digits, which yes, 1. We need division. 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22. Divide this with 9 and make this 8, so that we get a cool thing. X divided by 9 by y, and we get okay, this is the number of digits that we need. This is not shit, this is the number. I guess we can do brute force here. I think we can be brute forced here. In Max said his car is shit. Brute force won't work. It was very hard to do, but I cannot give some idea. Let's see. Regulations for the season are insane. Battery system and all. I think Russell is going to be shit. Maybe shit. Russell Bin Laden. Okay, from this we can conclude that we are after 23. The number that we need is going to have like this many digits. 6 9 1 2 3 5 6 8 into 3 24 10 power 24 digits. 9. So we can say that we are not going to have more than 5 numbers. 1 2 5. 5 is like the absolute limit. We are not going to have more than 5 numbers. Right. Brute force won't work. Let's see. So the number of possibilities. We are not going to have more than 5 numbers, which means even though it is said in the problem that s can be of length 10 power 5, that is false. That is like they are lying. That may actually not be false, because they might choose 3 digit. Okay, what can be the maximum in this range? The minimum number of digits they can have, well, minimum can be 1. We want to find out the maximum number of the maximum length of s. The maximum length of s. Let's say we are going, shit, our goal is to increase the length. Shit, length can be anything. What if the last number is 1 and before this we can have a very big number? which can be 1 followed by 10 power 6 zeros, because the sum of digits of this number is going to be 1, because everything is 0 except the first one. Length can be very big, something like this. In this we can insert as many number of zeros as we want in the middle. But I guess that is a special case. But we do have a cap on top of how many digits there can be, or yeah, how many numbers there can be. We can start with a big number, and then yeah, we will at max sum up the digits 5 times. Max we're stopping. Should they can just insert zeros anywhere and artificially increase the length. I guess our first goal would be in that case to remove the zeros and look at this without zeros, because zeros can just go legit anywhere. Should we can put the zeros anywhere except the first and the last, in between, and in between the string, anywhere in between the string. So we should remove the zeros and then look at the thing. Yep. And then look at the thing, remove the 0. Shit, we cannot just put zeros anywhere. Shit, yes, we cannot put zeros anywhere. We do need them. We do need them zeros. Because for this string 1991910 we need this 0 to be here, specifically here. If it was anywhere else, then that is a wrong move, because it becomes 1 1. Yeah, we do not have a 10 here, we need a 10 here. So yeah, 0 matters. Wait, how do you have 1 2 3 4 things on your... Yes, that is very cool. That is very cool. Look at it. Look at this. You also use a Mac, right? Look at this. Look at this. Shit. Like, I have so much power right now. It's very powerful. Look at this. This is workspace system like i3. Yes, you also need, everyone using map in Mac needs it. Aerospace. This thing. Aerospace is an i3 like thing in tiling manager. And also let me show you, if I open another terminal, it just does this. This is a tiling window manager. This is very cool. And these things at the top are called workspaces, and I have my own convention. Workspace number 1 will have always have the terminal. Workspace number 2 browser, 3 has the chat, and 4 will have Discord whenever it is open. It is not open right now. And this is the thing, workspace. This also has its own configuration file. Yeah, it is like, it is not very clean because it does not give you too much freedom, but it is very good enough. This thing, aerospace, it has its own configuration. Just like install this, they have a pretty cool video. There is a guy who has a video who explains workspace here. This one.
And command N again.
This video you can watch. This is pretty cool. And also let me show you my configuration of workspace, of aerospace. This has the same model of configuration as NewVim. Like this, it has a toml file for the configuration, and here you can specify what should be the size. And this is also model. That is like in Vim you have edit mode, insert mode, or normal mode. This is also modal, and I guess right now I'm in the main mode. I don't know too much about this, but there is a service mode, right? And these bindings work in the service mode. And in the video that I sent, he explains that in service mode there is a, like, if you press window shift semicolon, now you are in the service mode. This is S. And in the service mode, when you press escape, this thing reloads the configuration and puts you into the main mode. So if I press escape, I am like, configuration has been reloaded and I'm in the main mode. This gives you freedom. I press these to switch between workspaces, command 1 to go to 1, 2 to go to workspace number 2, and commands to move a screen window to some other workspace. This is just like pretty cool. I have defined here my own configurations for focus and for moving stuff here and there. It's pretty cool. And yep, there are these kind of configurations also. To open something, and also here this thing, whenever ghosty opens, whenever ghosty the terminal opens, like, push it into workspace 1 always. So even if I go to workspace number 4 and open ghosty, I do not see it because shit, it is already open. First of all, shit, because it is already open. Close ghosty, and if I go to workspace 4 and open ghosty, I go to workspace 1. That is where ghosty goes by default. This is just pretty cool. Yep, you can map your own. That is the beauty of this. And they have their default configuration. Pretty cool. Aerospace, I have uploaded, like, of course you upload your own configuration always to GitHub. And you can also switch what should be the gap between two windows if two windows are open side by side. This is very cool. This is just like very cool. This thing is very cool. Include hard is yes, it is custom built in Excalibur. I wrote this in Excalibur and took a screenshot. That is the wallpaper art. And cool shit, I guess that would be it for today. This is done. Contest is done. Contest was pretty bad. Shit, Kakashi, your rank must have gone up in this contest. I messed up with problem number 4. It was a bipartite graph. Yeah. Friends rating change. Shit. Okay, that is okay. 91 plus 91 plus 9. You're doing actually pretty cool. And wait, you did E also. Okay, that is crazy. You did E also. Shit, that is actually crazy. That is actually crazy. E, let's go. Dankeschön. Shit, you did E also. That is pretty cool. Let me, like, look at your solutions. First one, first of all. Yep, count. One is, yep, count one is cool. Count one is cool. While I smaller than n and I equals r, go to the right, and keep increasing the count. Okay. Shit. Okay, that is a very good observation. That is a very good observation. Shit, that is actually pretty cool. That is actually pretty. Shit. Yes, that is shit. Okay, okay, shit. I am like losing behind. This is pretty cool. Whenever you see a L, it is like bounce back. You can treat it as a wall. You will keep just bouncing back and forth. And this plus one is to count the first L that you see. Shit, that is actually pretty cool. What did you do here? Bad. Fill this up. Current max count equals 0. If I okay. Shit, wait, let me look at the problem. It was the maximum one. Yep, okay, yes, it is the maximum one. Take in current max equals 0 and count initially equals 0. You are going from left to right. You are going from left to right and you increase the count if and current max is initially equal to 0. Whenever the current maximum increases. Shit. Okay, you are getting like genius insights in all of this. This is also cool. This is also cool. This is shit. This is actually pretty cool. My solution was very retarded compared to this. This is pretty cool. If the current number is bigger or if the current number is smaller than the maximum number which you have seen till now, then it is going to be removed when you remove that maximum number. Shit. This is very cool. And how about C? Yep. AB LCM. Yep. ABC LCM. And A and by A, B and by B, C and by B. Yep. Number. These are numbers. Yeah, this is more straightforward. Yep. Plus minus plus minus. Yep. Plus minus plus plus minus plus minus and then plus. Cool. Yep. Shit. Shit. Kakashi, you are doing pretty cool. Have to go now. Have a good coding session. Yep. See ya. I was going to end anyway. This is stream. Yep. That would be it for today's stream. That would be it for today's stream, and thank you for being here. Bye. And Kakashi, you are getting good. Watch your back. Watch your back. I will be coming.